Okay, this is part 2 of quadratic word problems in factored form. So we left off on letter C. How many seconds after being launched will the rocket reach its maximum height? So we're looking for how many seconds. We're looking for our x value. We need to know what that x value is after the rocket is being launched and what its maximum height is at that point in time. So remember, maximum height refers to our turning point. So we are trying to find the x value of our turning point. And if you remember from previous lessons, the turning point for the x value is our midpoint. So we need to find the middle point of our x values of our roots here, which would give us our turning point x value. So we're going to take our -2 and our 18 that we found from our roots. To find x, we would take -2, add 18, and divide that by 2, because we're trying to find our halfway point. So -2 plus 18 is 16 divided by 2. 16 divided by 2 is 8. So it would take the rocket to reach its maximum height after 8 seconds in the air. Okay, so again, we're finding our midpoint, which is our x value of our turning point. And then the last part of this problem is finding the maximum height that the rocket will reach. So what is that maximum height? So we are finding our y value of our turning point in this case. So this is the turning point y value. And to do that, we do need our x value because we are going to plug in our x value of 8, okay, of our turning point. So we have our turning point at 8, comma, and we need to find our y value. We do so by plugging that x value back into our quadratic formula right here, okay, our quadratic function. And we have h of 8 equals -4 times 8 plus 2 times 8 minus 18. And going ahead and solving that, following PEMDAS, performing what's inside parentheses first, we have -4 times 8 plus 2, which is 10, and then 8 minus 18, which is -10. -4 times 10 is -40. -40 times 10, -10 is +400. So we have 400, and we know height is in meters, so 400 meters was where the rocket hit its maximum height after being launched before it hit the ground. Okay, so at this time you want to pause the video and take a try at the check for understanding on your own, then come back and see what your answers are. Okay, so for our check for understanding, Anna dives into the pool off a springboard high dive. Her height in meters above the water x seconds after diving is modeled by h of x equals -5 times x plus 1 times x minus 3. For letter A, how many seconds after diving will Anna hit the water? So we're trying to find seconds, so we need to find our x value. And as she hits the water, so again, a visual of Anna diving off a diving board and hitting the water. You can even get very visual and draw water on the bottom. So we want to know how many seconds, what the time value is in seconds when she hit the water. So we are looking for the positive value of our roots, because this was our high dive. This is where Anna was, and she jumped up, hit the water. So to find our roots, we take each one of our factors and set them equal to 0. Ignoring the greatest common factor, and we need to find the positive value. Eventually, you guys will be able to visualize x plus 1. We need -1 plus 1 to equal 0, so x equals -1 for our first root, and then x minus 3 equals 0. What minus 3 equals 0? X would have to be +3. We need our positive root in order for time, so 3 seconds after she jumps off the diving board does she reach the water. How many seconds after diving will Anna reach her maximum height? Taking, again, maximum height is your turning point. We need to add -1 plus 3, divide by 2 to get our maximum height. 2 divided by 2 is 1, so 1 second she would reach her maximum height.